Welcome to the webinar Introduction to Digital Dentures. It is being presented by Wendy A. Clark, DDS, MS, and we're going to begin shortly. And now I get to introduce our guest speaker for the evening, Dr. Clark. Wendy A. Clark completed her undergraduate training at the University of Georgia and earned her doctoral degree from Marquette University School of Dentistry. She then earned her master's degree in clinical dentistry and certificate in postgraduate prosthodontics from the University of Alabama at Birmingham School of Dentistry. Say that 3 times fast. Dr. Clark practiced prosthodontics for 7 years with Team Atlanta and lectured nationally on a variety of topics, ranging from smoking cessation to dental implants. She was named a leader in continuing education by Dentistry Today in 2017. Currently, Dr. Clark is full-time faculty at UNC Chapel Hill Department of Prosthodontics. And now it is my pleasure to say, take it away, Dr. Clark.
Thank you so much for that introduction, Jessica. I really appreciate it. This is my favorite topic. I was saying I was just going on and on about digital dentures. I am a consultant and a key opinion leader for some digital denture companies, including Avident, Dentsply Sirona, and TrueDent, as well as 3PX Software. None of them are sponsoring me financially for this lecture. When we think about the history of dentures, this shows Dr. Giese making a denture back as early as the 1920s. And a lot of these things might look really similar to when you were in dental school learning to make dentures. You'll see similar face bows, bite forks, centric relation records, Gothic arch tracers, and a lot of this brings up traumatic memories for us from our dental school days. And moving forward, all of that has been adapted into really fantastic, innovative features. This is the first digital denture workflow that I ever used, and this was with the Dentka company. And so they have a specific workflow with their specific trays. And the reason why I got so excited about this was they had a Gothic arch tracer built in. And it really opened up my mind to different opportunities and the way that innovation that we're utilizing in complete dentures was truly built on all these foundational concepts. So while we think about digital dentures as something brand new, none of the aspects of digital dentures and none of the physical characteristics and the steps are something that we just pulled out of thin air. Everything is based on landmarks and physiology and history and all of this evidence base that we've been working on for the last 120 years. So I just think this is so exciting, and to see this side by side showing this innovative workflow that works with printed dentures and CAD design compared to Dr. Giese in 1920. And so 100 years later, we're utilizing these same concepts, but in a way that's more user-friendly and streamlined for private practice. So let's move forward from 1920 all the way to 1937. The year the Hindenburg exploded, Amelia Earhart took her flight across the ocean, and FDR was president. That was the same year we started processing complete dentures with polymethyl methacrylate. And these press pack dentures shown in these flasks could be from 1937, but they are from about the 2010s. And these are some cases that I was working on with one of my labs. And I just found it fascinating that the same protocol barely changed in nearly a century. Move forward to the 1980s, we think about CAD/CAM dentistry, again, as something a little bit new, cutting edge. We've been using CEREC since the 80s, y'all. That is before every single one of my dental students was born. And so it's just fantastic to think about how long we've been ingraining this technology into our practices and weaving it in and the advancements we've made. Because I don't know about that computer on the far left, but I imagine that the crown took a really, really, really long time to mill. Digital dentures came up with their first proof of concept in the early 90s. The research was begun in about 1991, and this publication came out in 1994 in the International Journal of Prosthodontics. And this paper by Maeda was the first proof of concept in the literature, the dental literature, about CAD/CAM dentures. And of course, things have become more streamlined, more predictable, and more commercialized, but we've been working on this for decades now. This is one of my new favorite historical literature articles from all the way back in 2012. In 2012, digital dentures became commercially available, and at that time, there were only two possible workflows. And this review paper from the California Dental Association had reviewed each of those workflows and how to incorporate them in your practice, the types of materials and techniques. One was from Avident, which became the printed denture, I'm sorry, milled denture workflow, and one was from DentCat, which became the printed denture workflow. And walking through these workflows, there were certain materials you had to use. Some of them wanted specific impression materials. You were locked in to one single lab for each of these. You had to use a certain bite technique. So you were really, really, really limited in the workflow you could use. And you couldn't stray. If you wanted to work with this workflow, you had to follow step A, B, C in that order without deviating. And today, we are no longer locked in. So going from those two workflows, we have open source softwares that you can use this software for this printer, this software for this mill, this software can be sent to this lab. The scanners are all open now. They used to be locked down, so you could only send to certain places. The home computers became much more affordable and feasible for a private practitioner to purchase, especially the machines that are big enough and powerful enough to run the design softwares. Next, we had the FDA clearance of resins in 2015, which again became commercially available around 2017. And then we really started to see things open up at the very end of 2019, right before the pandemic, when we had high impact printed resins that were starting to have improved physical properties. So now we have the software, we have the hardware, we have the workflows, we have the materials, we have the labs, we have the scanners. And so today in 2024, there are unlimited workflows, unlimited options you can make digital dentures. So my hope with this presentation is to kind of introduce you to digital dentures, what they are, how you can start to break into some of the workflows. And the next presentation, we'll give a little plug at the end. I'm going to really delve deep into some of these workflows so that you can embrace them and incorporate them into your practice. So the first thing to understand, after all of this data, all of this work we've done, today, any step of dentures can be digitized or not digitized. And I think this is really exciting as a prosthodontist because you might know that many of us are a little bit type A. We like to have control over different aspects. And there are some cases that I want to use a face bow. There are some cases that I want to do lateral check bites and protrusive records and set my articulator. Sometimes I'll use a Kadiax and get a little wild and do some jaw tracing. Sometimes I'll use green stick compound. So I can take any of these conventional steps I want and incorporate them into a digital workflow. Or likewise, I might just want to use my scanner and not pick up my PBS today. I can do that too. And it's super exciting that you can take any step you want, make it yours, find the workflow that fits for you and your practice and your patients and your lab. But if you haven't done a digital denture yet, that can be kind of overwhelming. So where do you start? How do we break in and find our way into this workflow? Every single digital dentistry workflow, including digital dentures, has all the steps fall into one of three buckets. And those buckets are data acquisition. So bringing in data about your patient. It could be an impression, a photograph, a bite registration, a CBCT. And then you take all that data that you've acquired and put it together in your design software. So this is the CAD part of CAD-CAM. CAD-CAM is computer-aided design, computer-aided manufacturing, and that CAD part is the step 2, which is the design. Once you've designed whatever you want to fabricate, you roll into step 3, which is the CAM part of CAD-CAM, computer-aided manufacturing, and that's where you start to create the smiles that you've designed. And this is what it looks like for the complete denture workflow. We get our impressions, we get our records, we roll in and we do our digital smile design. We put the teeth and the flanges where we want to. And then last but not least, we print or mill our dentures. So looking at the conventional denture workflow, this is what Dr. Giese taught his students in the 1920s, and it is what I teach my students in the 2020s. And everybody in between has taught the same thing. So if you have been to dental school, this is more than likely the workflow you learned. There are a handful of schools that deviate and do a shorter condensed workflow. but studies have shown that the very vast majority of preclinical prosthodontics, predoctoral prosthodontics teach the 5-visit workflow with the laboratory steps in between. So I will not belabor that because we've all been there. And to kind of show, compare and contrast the difference with a digital denture workflow, this is what we're looking at. And so it looks a lot smaller, it looks a lot more condensed, but the most important takeaway here is that we're not eliminating anything. We're not eliminating interocclusal records, we're not eliminating impression. We are still doing all these steps, we're just combining them and consolidating those steps into a way that makes it easier to bring into your practice. So when you look at all the different workflows across the board for digital dentures, and we'll walk through several of those workflows in this presentation and the next, the average is about 2.5 visits. So there's a number of 2-visit workflows, a number of 4-visit workflows, and a number of 3-visit workflows. And when you balance them all out, they come up to about 2.5 visits. And you get to that fewer visits by combining steps, and it's typically that record step. Where I went to school, we called it maxillomandibular relations for MMR. Some people call it JRR, jaw relation records, but it's really taking that relationship between the maxilla and the mandible, the vertical and the horizontal, and combining that step either with the impression appointment or with a try-in appointment. And we'll show you how those work. To put that together in words, you start with impressions. You can't make anything ever in prosthodontics without some sort of impression. You have to get an interocclusal record. Again, we can't make anything without an interocclusal record. We can do an optional try-in appointment. So when you see the 2-visit workflows, we're eliminating the try-in, and then we'll insert our prosthesis. So let's start at the beginning, all the way back to impressions. And you'll see across this slide, we have a lot of different types of impressions, from alginates to a PBS border molded impression, all the way to a digital impression. All of these are fine. These are all great preliminary or final impressions for complete dentures, depending on your workflow. And that workflow is going to look different depending on your philosophy. Do you believe in custom trades? Do you have a scanner or a printer in-house? All of these things are going to play into what works best in your hand. And when you take everything into consideration, today, still in 2024, conventional impressions are usually the starting point for most digital denture workflows. And then you get into the digital workflow by taking that impression. You can either pour it and scan the cast, or you can scan the impression directly, and that will bring you into the digital world. And this is kind of the secret sauce. How do you go from conventional to digital? It's the scanning of the records. And you can utilize a benchtop scanner, sometimes called a tabletop scanner or a laboratory scanner. And this is any scanner that does not go into the patient's mouth. So it's an extraoral scanner. You can take impressions and put them in there, wax rims like you see in this picture. You can take a patient's existing denture and it'll rotate all around, capture 360 degrees, whatever item you put in there. And then that becomes digitized into a 3-dimensional file. If you have an intraoral scanner, like many of us do now, you can utilize that as well. Most of the big scanner companies have now created a module within their user interface that you can use your scanner for removable workflows. And most of them will ask you, are you scanning an impression? Are you scanning a denture? And you just tell it what you're scanning and you go to town. Hit the button and scan everything. The one thing that I have found and that I've seen consistent with companies is that it actually works better in most scanners if you start by scanning the impression first and then rolling around and scanning the denture teeth, which is kind of counterintuitive. When I first started working with scanning dentures back in the early 2010s, I would scan the occlusal table and then roll into the impression, and it doesn't seem to stitch as well. And as we've started to develop some protocols with the different intraoral scanners, we found that it's actually better if you scan the impression first and then roll around onto the occlusal table. And what this does is it allows you to preserve those records throughout the duration of treatment and even afterwards. And this preserves everything. So when you scan your impression, you are preserving that final impression record as long as you're working on the case. Certainly you can scan the intraoral tissue, and this is becoming a more and more common workflow. Lucio LaRusso worked with 3Shape and came up with this scan path pattern. This was the first documentation, the first validated workflow for an intraoral scanner to scan soft tissue. And what he does is he shows that when you scan in this order, where it's 1, 2, 3, and 4, that will give you the most predictable image and the most accurate digital cast. And this article is online on the 3Shape website that you can go and grab that free of charge. No matter if you're doing a conventional impression and scanning it, pouring a cast and scanning it, or scanning intraorally, it is absolutely critical that you capture all the patient's anatomic landmarks. So all of the rules that apply to your border molded final impression still apply if you're making an alginate impression or an intraoral scan. You need to be able to see the patient's soft tissue landmarks. You need to especially see that posterior area with a retromolar pad and the tuberosities and the vibrating lines. So make sure that you are capturing your patient's anatomy as you go through these workflows. If you choose to start with a scan, there's a lot of ways you can go through there to get to your next step. So the kind of the most clunky and analog to digital back and forth is to scan, print the casts, and make conventional custom trays. Usually what I will do when I start with an intraoral scan is I'll scan the soft tissue, and then I'll jump into a software where I can design and print either custom trays or record bases, depending on the case. And then I can jump right into a wax rim workflow. Or you can scan and utilize proprietary methods, the centric trays and the centric records from Ivoclar. You can start with a scan, or you can scan and go to a Wagner Trian, and we'll walk through that Wagner Trian in the workflow section on the next webinar, but it's combining a wax rim and a tooth Trian. So let's talk about step 2, which is the trial denture. So we've gotten our preliminary impressions or our final impressions, depending on the workflow you choose, and now we're ready to go to the next step. There are 3 different types of trial dentures that you can use today, and going from most digital to least digital. We have the monolithic Trian on the left, and this is going to be a one-piece, usually 3D printed, but it can be milled Trian. And on the right, the far right, you'll see a conventional wax tooth arrangement. And then in the middle, we have kind of the half and half, and this is the Wagner Trian, where we have the maxillary teeth set in wax. And then the posterior teeth are printed blocks, and we have wax on the lower arch. So we'll go through each of those step by step. The first is monolithic trial denture. I would love to spend a little bit more time on this one because to me, this is where the future of dentures is going. If I could predict one thing that's going to happen in complete denture land and complete denture protocols, it's that we're going to start to see less and less and less wax. This is a lot easier for laboratories to send back and forth. And so dental laboratories love working with a monolithic trial denture. It's easy to do in-house. You can send data back and forth with your dental laboratory a lot easier. One thing that's really lovely is you can utilize an FDA cleared resin. And if you do that, your patient can actually wear this prosthesis home. There are so many benefits to letting your patient try your monolithic trial denture. So if you think about the conventional wax workflow, we have our patient try on the denture, look in a mirror for 5 or 10 minutes and say, well, do you like it? Can we process? Will you sign this paper so that we can process it? And if it doesn't look like what you want, you have to pay for it. And it's just a really intense appointment when you do a wax tooth trying and try to get those answers and try to find if that's what your patient wants in that very short amount of time. In addition to being a short amount of time, the wax is pretty unstable. And one of the bigger pain points for me is when I'm trying to evaluate occlusion, but the wax starts to soften. And so the patient bites down too hard, and now we've closed the vertical. More often, number 7 or 10 falls on the floor, and we're trying to get it sanitized and sterilized and put back into the denture. Or we let the patient look at the denture without number 7 and or 10, and they're like, well, I'd like it better with all the teeth. And so there's a lot of pain points that come with a conventional wax tooth Trian. They can not only evaluate the aesthetics, but they can actually wear this home and they can try to eat with it. So now we can evaluate not only aesthetics and speech, but also function. They can try to chew with it, speak with it, and they can show whoever they want. So they can wear it to work and show their colleagues. They can wear it to their kid's house and get their opinions. And so it's a really great opportunity to really truly see how this is going to fit and function, rather than that very short wax tooth trying appointment we do. The next stop is going to be the Wagner try-in. This is our half and half digital conventional try-in. The maxillary anterior teeth are individually set in wax. So you can actually move the maxillary teeth the same way you would move a conventional wax tooth try-in. This is actually the first workflow we incorporated at the university when we were trying digital denture workflows, because this maintained all of the things that us classic prosthodontists were used to and all of those teaching tools that we're used to. So here, a student would get the opportunity to learn to move teeth in wax, because they have the maxillary teeth that they can move. They can set the midline, set the incisal edge, set the gingival margin with those teeth. But then they get to also do the MMR appointment. So now they can adjust the vertical dimension, establish CR using centric relation, the same way that we normally do with our conventional dentures. So the clinicians, the faculty, didn't have to learn anything really new. They just get to take this next step towards digital dentures. And this was I call this the gateway denture, because it's a really nice workflow for clinicians that are comfortable with conventional, but want some of the benefits of digital. With a conventional wax tooth try-in, this is our standard workflow, so I won't go too deep into this because we've all done one of these before. The main benefit of this is you get to see what the final teeth are going to look like, because these are the definitive denture teeth that you're trying in here, and you can move them. So if you are a person that likes to move teeth in wax, then this is going to be a workflow that you're more comfortable with. You certainly can do a conventional wax tooth try-in, scan that in and print or mill a denture base, or just scan it and preserve a copy of your wax tooth try-in. So if the patient loses their denture, you can always repeat that without having to go through all the steps again. The biggest downside, of course, is that the cost associated with this. Denture teeth on cards are very expensive. And if the patient doesn't like the shade or the fit isn't right and you end up having to grind the teeth and get new ones, you repurchase that entire card of denture teeth. And depending on the tooth card you use, some of the high-end denture teeth are $100 or more per card. So sometimes you're investing $200 to $400 just in denture teeth alone with conventional workflows. No matter which digital try-in you use, whether it's a conventional wax tooth try-in or a monolithic try-in, we're utilizing our try-ins to establish these three things. We need to establish the vertical record, which is the vertical dimension of occlusion. We typically teach the technique of vertical dimension of rest, minus 2 to 4 millimeters, and to get our vertical dimension of occlusion. There's a ton of ways to do it. There's nothing wrong with any of them, but you do need to establish a patient's vertical dimension of occlusion and where they can function most comfortably. The second is horizontal record. For the majority of dentists, this is going to be centric relation. There are some philosophies where we can use a muscular position or an MI position, but typically we are utilizing centric relation. So that's our horizontal record. And last but not least, we have the orientation record. I'm going to do a trigger warning before I say this. This is where we use our face bow. In digital dentures, we do not use face bows most of the time. The orientation record with digital workflows is going to be a full face photo. Taking a full face photo with a patient looking straight on will allow you, the clinician, or the technician you're partnering with, or a combination of both, to do what's called a digital face bow. So you can take that photograph and actually pull it into the denture design software so that you can orient the patient's face and the patient scans together and establish a more appropriate occlusal plane. So now we've gotten through our data acquisition phase. We've started our design to get our print. Now we're ready to fabricate. With digital fabrication, there are two general types. The first is going to be milling, which is a subtractive manufacturing. And the second is going to be printing, which is an additive manufacturing. And some people call this rapid prototyping. With milling or subtractive manufacturing, it's subtractive because you have a puck of something and then you grind out whatever you're trying to create. So many of you may have seen a CEREC machine where you have the puck and then you mill the crown out of it. There are bigger mills like the 5-axis and 7-axis mills where you have a hockey puck that goes into the unit. It's called a puck of material. It looks like a hockey puck. With dentures, that puck is made of polymethyl methacrylate, or PMMA. If that sounds familiar to you, it is the same thing we were using in 1937 to make dentures. So that material that we've been using is actually the same material that we use in subtractive manufacturing or milled dentures. And we'll talk about that in just a few slides. And I always say that when you mill a denture, it's kind of like Michelangelo chiseling David out of marble, except more beautiful because we are chiseling a denture out of polymethyl methacrylate. With printing, it's an additive process. And so you have a vat of resin. That's the most common type of printing, and we'll talk a little bit about that as we go down the line too. But you'll have a vat of uncured resin, and then a laser or some sort of light will cure that resin and build it up in layers and create your denture. And if you think about way back in first year dental school, when you learned how to do your composite, we would layer the resin, we do a layer and cure it, we do a layer and cure it, we do a layer and cure it until we created our tiny class 1 restoration. That is essentially what the printer is doing, but in much finer layers. And you can go down to 10 microns, 50 microns, whatever you put the settings at. And so you're creating these very small micron layers, and each one gets cured and builds up whatever you have designed. So milled dentures are made of polymethyl methacrylate, exactly the same as a conventional denture. What is cool is when you press pack a denture, when like in the flasks that we showed at the beginning from the 1930s, you put all the resin into the flask, pack it in, and then you let that cure. You go through this whole cycle of polymerization, and there's always shrinkage, and there's always polymerization shrinkage away from the cast. So when we do our posterior palatal seal in the back of dentures, one of the reasons is to accommodate for that error that's inherent in denture processing. With milling, all of that error is gone when the puck is made. So they take the powder, they take the liquid, and they industrially pack it into this puck shape. And that is when it shrinks. So what that means is when the denture is actually milled, the polymerization shrinkage is all gone. So you're actually getting a true 1-to-1 fit from your design to the milling of the denture. And so you get a more precise fit with milled dentures than you would with a conventionally processed denture because of that. So it pre-polymerizes before the denture is made. When you mill that denture base, you can just mill the base alone and create these little sockets within it, and then bond carded denture teeth. And so now you're using these conventionally carded denture teeth with a milled denture base. You're capitalizing on the better fit and adaptation from the mill, but you can still use a carded denture teeth if you prefer the aesthetics and mechanical behaviors of those. A lot of clinicians that have been doing dentures for a very long time or do a lot of dentures in their practice are very partial towards specific brands of denture tooth. I like the P6 mold from Dentsply Portrait. I'm just teasing. I like all the molds. But a lot of clinicians become very partial to a certain brand or a certain mold or a certain aesthetic, and you can still use those same denture teeth in your denture base. If you prefer something a little different, if you don't have a denture tooth you love, for example, you can use a monolithic denture. This, to me, was so exciting when I learned about this several years ago. And what they do is when they make that puck of polymethyl methacrylate, they're actually putting the tooth shaded PMMA and the denture base PMMA into the same puck. And so this is all prefabricated before the design is milled. And what you see here is the denture teeth are now part of the same product as the denture base. So what that means is there's no separate denture teeth. So you won't have denture teeth debond, which is the most common error we see with complete dentures. So, or the most common post-op complication will be denture teeth debonding. Here, there's no teeth to debond. And so when you think about the clearance that you need for a denture, you usually have to have 2 to 4 millimeters for the denture base resin and 2 to 4 millimeters for the denture tooth resin. So the minimum denture space requirement is going to be about 8 millimeters. 6 to 8 millimeters. And with a denture that is monolithic, now you can condense that down even more. So if you have a limited space patient or a patient that keeps debonding denture teeth, this is a fantastic solution because you don't have to worry about those pop-offs of the denture teeth. We talked about the polymerization error. That's when the cast pulls away while it's being processed. With milling, again, the processing is all done, so you don't have to worry about that misfit that happens sometimes with processing error. There have been a number of studies that show the improved physical properties, particularly with milled dentures. It shows better fracture toughness, less porosity, less Candida albicans adhesion. So more kinder to the tissue, we see healthier tissue and fewer fractures. So after milling, we have 3D printing. So this is the additive manufacturing technique of making dentures. And you have this vat of uncured resin, and it's being cured in layers by a laser light. And as it rises up, you'll start to see that the layers that built into a denture. Those crossbars that you see across the front are to help maintain that stability during printing and post-processing, so you have more accuracy of fit as well. When you print resin, it is not polymethyl methacrylate, so it's a different material than you see with either milling or processing. It's usually a methacrylate polymer, so there is some methacrylate in it, so you can utilize denture-based repair materials with the printed resin. They just don't behave as predictably as they would with a processed or a milled denture. After you design your denture and your denture teeth and your denture base in the CAD software, and you go to print it, you do a step called nesting. And so this is showing nesting the denture bases on a platform and nesting the denture teeth on a platform. And you'll notice they are nested separately because with 3D printing right now, you can only print one color at a time if you're using vat printing. And so what that means is you print the bases, you change out the resin tank, and you print the teeth. This is going to vary widely from printer to printer what that looks like. And then no matter which printer you use, you have to nest it. This is a fantastic opportunity for dental labs. And so when we start working with different dental laboratories, you'll find that many of them are leaning towards printed dentures versus milled dentures. It's because if you look at the left, you can see there's 3 denture bases nested in a row. If you flip this to the other side, there could be 3 more. So you can nest and print 6 to 10 denture bases at once, depending on the type of printer you have. And the same thing on the right, you see these different arches of denture teeth all nested at once. So usually you can print multiple arches of denture teeth as well. So there's a much better ROI if you're a dental laboratory or a very high volume practice that wants to make their dentures in-house, because you can print so many denture bases and so many teeth at once. When you mill, you can usually only mill 1 arch of dentures at a time. So we print the bases, we print the teeth, and we bond them together. And again, this workflow is going to vary from resin company and printer company. And they all have different resins. They all have different curing temperatures. Many of them have their own curing units. Some of them you have to cure at specific temperatures. And so you want to be really careful when you start printing dentures in-house that you have all the appropriate equipment and chemicals and understand those steps. Usually we'll call all those steps after getting it out of the printer, post-processing. So you'll bond the teeth, you'll cure it at the appropriate temperature and the appropriate wavelength of light for the appropriate amount of time. And then you create a denture. So that's how a denture is born. And this material was FDA cleared around 2015 and first commercially available in 2017. When I found this out, I was so excited. So I started printing all my dentures. Whenever I try a new material, I'll usually make 2 sets for my patients. So I make 1 set with a material that I'm very comfortable with, and 1 set with a new material. So I can kind of beta test in a lower stakes environment, and I won't ever leave my patient without teeth. I did the same when I started my printed night guard. So here, this shows an array of my first printed dentures in 2017. And you can see all the different failures. And I think this is really cool to see that we have the mixed failures where it's kind of cohesive and adhesive. We have cohesive failures through the denture teeth. We have adhesive failures where the bonded denture teeth actually debonded. And you see, even though we were bonding them in segments, the entire segment fell out. So that was interesting. And then on the right, you see this very stained denture. This was an immediate denture I made for one of my patients, and I saw her at the 24-hour recall. And this is how much stain she had accrued in that first 24 hours. So fortunately, we've worked through many of these kinks, and in just 5 short years, we've seen such vast improvement in these resins. So 2019, 2020 is when we started to see the release of the high impact resins. Those high impact resins are now in the second or third iteration or second or third generation of high impact resins, depending on the company. And so this was one of the newer high impact resins that was released in 2022. And you can see that we've really improved some of the aesthetics. The teeth look a lot more natural. One of the things I think is the coolest about printed dentures, if you look at the anterior area of this, you can see that they've done a lot of stippling. We've really characterized the anatomy from the canine eminence and around the frenum and the gingival margins. And so anything you put in the software, the printer can create. And that's not always the case with milling because we're limited by the size of the mill and the size of the burr and the position of the burr in the mill. So a mill can't recreate all these really precise undercuts and this really small anatomy the same way that a 3D printer can. A 3D printer can print anything, no matter what the geometry is. Now in 2024, you went to the last lab day in Chicago, the hot topic was jetted dentures. And what jetted dentures are actually monolithic printed dentures. And so you can see in the bottom photo, there's several different dentures on this printer bed, and they have a different type of way that they're nested. So they're kind of encased in these little cocoons. And what that does is it really preserves a lot of the anatomy as well as the fit up against the tissue. The really cool thing about jetting and why I think it's going to be the hot topic for a little while is you can print multiple different colors at a time. So that's how they have the denture base and the denture teeth in one piece. The software knows when to switch from pink to white. You can actually characterize the tissue with different shades if your patient has a lot of pigmentation. And you can characterize the teeth. So you can actually make each tooth in the arch a totally different color if you want to. And so all of these dentures on this print bed might be and probably are all different colors. And I think that's really exciting. They say it's similar to an inkjet printer where you have all the different colors that can be mixed at whatever ratios the computer tells it to. So this is, to me, super exciting. We see the physical properties, the aesthetic properties, the fit properties improving so rapidly. I mean, from where we started in 2017 to where we are today is night and day. The bad news is we don't have a lot of evidence base, like journal evidence base that we look for as clinicians. What we have are manufacturer studies, which we know are often biased, and clinical experience from people that aren't afraid to break things. So hi. So I'm always happy to share my clinical experience. And if you go on social media, you'll see a lot of other people that are sharing their experiences as well. The good news is that experience seems to be generally positive. This is a video from a local dental lab that they refer to as a redneck scientific experiment where you run over dentures with a monster truck. And what they found was the printed and milled dentures did not break, and the processed denture that you ran over with a monster truck shattered. So if you're going to be using a monster truck to test your dentures, you might want to go digital. One thing about printed resins is that printers or printed resins are not all created equal. And this was a study that we ran with one of our pros residents in the last few years. This was just published in Journal of Prosthetic Dentistry, where we found a really vast difference as far as the topography or the surface texture with different dentures. And so the printer on the right, you can see had a more significant or statistically significant difference in roughness than the other resins. Now, all of those were within clinical acceptability. So none of those were so rough that they wouldn't be allowed to be intraoral use. And same when you look at these underneath a scanning electron microscope. So the two slides, right and left, look pretty different as far as the surface topography goes. These are just two printed resins that were printed on two different printers, and they were set to the same resolution. So they should have been pretty similar, but just the variation in the printer technology and the variation in the resin itself changed that surface texture. And so looking at printed protocols, there were two fantastic reviews that came out around the same time in 2020. One came out of Loma Linda University and one came out of University of Pennsylvania. Both outstanding if you have access to either of these articles. But what they did was they went through the current workflows we're using with 3D printing, kind of the state of where we are now and where we're going, and both found very similar things. This is such a promising technology. The workflows are so adaptable. It makes sense to use printing, but we don't have enough evidence yet. So keep your eyes open, keep reading the journals, because this seems to be like where we're going. I'm going to touch on just a few basic workflows, some of the highlight reel to tease you for the next webinar. And when you look at digital dentures, there's so many different ways you can go. So something that I've been working on is trying to create some flow charts and resources for my dental students and anybody else that's interested to kind of help make sense of where to go next. And so this is a decision tree that we've been working on with where do you go when your patient comes in? Do they have teeth? If they have teeth, you're going to go with an immediate denture workflow, and we have a separate flow chart for that. If they have no teeth, do they have a denture? One of my laboratories that I work with found that about 80 to 90% of patients that come in actually come in with an existing denture. So we'll talk about those types of workflows as well. This is my immediate denture flow chart that I use with my dental students. And this is kind of that basic wax rim workflow. So patients that come in with nothing. This is a super basic starting point for making digital dentures for patients with nothing. And you start with some sort of impressions. Usually it's going to be a scan or an alginate. And from there, you can either digitally or conventionally make a wax rim. And then that wax rim is used to take your final impression, your vertical, horizontal, and orientation records, and then you'll roll into your monolithic trine and your final denture. So since the majority of patients come in with something, we'll start with that workflow. And the question is, when they have a denture, do they like it? And do they just want a backup copy? Or do you want to make some sort of changes? Are you changing the tooth position, the flange extensions, aesthetic contours, anything like that? If you're going to make changes, we'll do the reference denture workflow. With a reference denture workflow, you take the patient's existing denture and you're going to use that to get your definitive impression. And you want to evaluate, is it overextended, underextended, and that'll kind of dictate the impression material you use. There is not a material you have to use. In this case, we're using polyvinyl siloxane. That's what we teach our dental students. If it's short, we use a heavier body or a heavier viscosity PVS. And so you can see we're border molding on the right with a heavy body PVS. And then we're going to take our final impression with a lighter body or lighter viscosity PVS. You'll see me putting tray adhesive. This is whatever adhesive goes with your impression material. That will come off of the denture if you use rubbing alcohol on a 2x2 is usually what I use to wipe it out. So when you're using the patient's existing denture as a reference denture, you don't want to do anything permanent to it that's irreversible so that they can go home with their prosthesis and continue to function with it. The lighter viscosity material is going to really capture that fine detail. And so this is how we get that great support and intimacy of fit to get that retention. After you do your impression, you get your interocclusal record, which is your horizontal and vertical and orientation record. So you want to do the impression first. I think if you don't learn anything about workflows today, that would be the one thing I would advise is whenever you're doing any of these steps for a conventional workflow, a digital workflow, reference denture, it doesn't matter. You always do the impression first to stabilize the base before you take your records. Whenever you put the impression material in, it can shift that base even very slightly, but that can be enough to completely throw off your occlusion. So always do your impression first and then get your interocclusal record. With that impression material in stabilizing the denture, take your full face photo. This is going to be your orientation record so that you can pull it into the design software and really get a nice smile design customized for your patient. If you take the photo before you put the impression material in, again, you might shift that midline, shift the incisal plane, shift the gingival display, and that can affect the design that you do with your dental technician. So do your wash impression first, stabilize that base, and get your full face photo. The most important thing here is that the patient is looking at the camera straight ahead. If they turn their head to the side one way or the other, then it's going to be hard to align that patient's existing denture into their smile design. And you also want to, if possible, see the patient's ears. That helps align the digital articulator. So border mold first, then do your records. Take your impression first, then do your records. And then once you've made the changes you want, you can scan your denture. If you're doing a monolithic try-in, you can scan that as well. This is showing with an intraoral scanner, just picking that up with a hand scanner. Again, this time I started with the teeth and then rolled onto the impression. We were doing kind of a study to see which one was the most accurate, and we did find that it's easier to roll from the impression to the teeth. And then you can scan your interocclusal record as well. So at the end of the day, what you want to have digitized are the definitive impressions inside the denture, the interocclusal relationship. So you want to make sure you can see the teeth going along the side and how they interdigitate, and that incisal or occlusal plane. So that will help you determine curve of spee, midline, tooth display, and incisal plane. Once you have your scan, all that data is digitized. Now you're going to jump into your design steps. When you do your digital design, it can be completed by the clinician if that's something that you're really adept at or something you're very interested in. Otherwise, if you're kind of new to the process and you're trying to decide which workflows for you and which steps you want to take, this is a fantastic step to delegate to a dental laboratory technician. The software that they use for digital denture design is usually very similar to what they use for fix. So the 3Shape software, for example, InLab software, Exicad, they all have fixed modules and they all have removable modules. So if your technician is very adept at doing your all-on-X hybrids out of zirconia, the software is almost identical as they do their digital smile design for a complete denture. And then you'll jump into either a monolithic try-in. So for the reference denture workflow, you can do your impressions, your bite, your scan, roll into a monolithic try-in to verify everything, or if you felt really confident, you could go right to final. This gives us an opportunity to talk about the monolithic try-in. So we're going to pretend like we always do try-ins. In this case, it's a paradigm shift for us clinicians that are very used to working with wax. So my armamentarium no longer involves a Bunsen burner and a number 7 wax spatula, but now I'm bringing in Sharpies, and I get to use e-cutters, which I really love using my Dremel and grinding on that with a big fat pineapple burr. So at least I get to still do that. This is a clinical checklist that goes step by step through the monolithic try-in. This is something that's online. It's a free resource. I love free resources and I love checklists. I've created a whole series of checklists for my dental students. If that's something you're interested in, if you reach out, I'm happy to share that. I have it on Dropbox. I'm happy to pass it on over to you. But this checklist was created by Valerie McMillan, who is the denture queen on Instagram. And she made all these very simple yes or no questions. Is your denture retentive? Is the VDO correct? What kind of changes you want to make? And this becomes a really great talking point between a clinician and a technician if you're outsourcing your design. So you can use the same form at the first appointment if you're doing a reference denture workflow and you want to go straight to the final, or if you want to discuss the design with your technician. And I think one of the biggest hurdles to overcome, and this is the biggest problem that I've had when I'm training new dentists in this workflow, is that the monolithic try-ins are made for you to modify. So if you think about it more like you're doing a trial smile for veneers or crowns or implant fixed prosthetics, we're usually not afraid to adjust those to protect our implants or to finalize our occlusion or to improve the aesthetics. But for some reason, I think we have this hesitancy to grind on these dentures because they look like the final denture. And with conventional denture teeth, you don't want to grind on them like crazy, of course. But monolithic, it's just a prototype. So same type of prototype as if you're doing a fix or an implant restoration. And when it's off, go to town, pretend it's a wax rim. And so you can see on this photo on the left, we were probably about 6 millimeters too long on our incisal length. So I just took my fattest E-cutter, cut that down to where I wanted the incisal display to be. And then I came and carved my high smile line. So now when I put this into the software, I'll be able to see where the incisal edge should be and where that cervical margin should be. The one on the right, I think, is even cooler. This is one that my colleague did, one of the general dentists we work with, actually took the monolithic trident and put it on the diamond wheel, the model trimmer, and just laid into it and took it down to the level he wanted and literally turned it into a wax rim. So you don't have to be afraid to modify these things. They're all going to be redesigned to go into the next step. My one commentary here will be, if you do end up making this many changes, if you have to make a notable change to the vertical dimension of occlusion, then you're going to want to do a separate monolithic trident, a second monolithic trident after this, rather than going to final, as in this case. So again, if everything's great, small changes, go right to final. These are two different YouTube videos that walk through the reference denture workflow. If I went a little too fast, because I do talk fast, it's just the way I talk. I'm sorry. It's not you, it's me. Go ahead and grab a screenshot of this and these videos. The one on the left is shorter. It's about 3 minutes long. The one on the right's a little longer and more detailed. So if you're a novice in the reference denture workflow, the one on the right will have a little more detail for you. So let's wrap this up with a big picture. Why are digital dentures becoming so popular and having so many webinars and so many CE courses at the big meetings? There's a lot of benefits we went over today. They avoid some of the material error we see with conventional processing. We preserve the records from start to finish, from the primary impression to the final denture, and the workflow's consolidated. Not just the steps of the workflow start to finish. This was a retrospective study we ran at UNC, where we found that the dental students used far fewer appointments case to case for digital dentures versus conventional dentures, but they also had fewer post-op appointments. And I thought that that was really exciting. So the digital dentures typically had fewer post-operative adjustments than the conventional dentures. And when we think about completed dentialism, there are about 300 million people worldwide that are missing teeth. So we are looking at an epidemic of total edentalism. And there are a lot of dentists that don't think dentures are very fun. So sometimes it's hard to find a provider locally that can provide these services for their patient. On top of that, there's a strong association between socioeconomic status and missing teeth and total edentalism. And so the patients that need us the most often have the hardest time getting to us, especially if they have to travel quite a distance. And so if we can create more providers that can help these people, then perhaps we can overcome some of these hurdles. Also, if you think about the invisible burdens, patients have to take 5 appointments off of work. 5 times they have to find childcare. 5 times they have to find transportation sometimes. And when you tell patients at that first appointment, I can make you a denture, it's going to be 5 to 6 appointments with 2 weeks in between each appointment, it can be overwhelming for patients. If I can say I can make you a denture in 3 appointments, a week or 2 between each, it becomes a lot more palatable and a lot more available to more patients. So these digital workflows can help decrease some of those invisible burdens that are blocking access to care for these patients. On top of that, my dreams are that my dental students will leave school and really embrace this technology and embrace these workflows and not be afraid of dentures the way that my colleagues were when I graduated dental school in 2007. So I see this new generation, they're sending me messages on Instagram showing me their dentures that they're making, and I just see that we're overcoming some of these hurdles, and I think it's really exciting. So I hope that you can learn to embrace innovation with me, because if we didn't, we'd still be making dentures like George Washington's, and I would not want to make that type of denture. So thank you for spending this hour with me.